Welcome back, Math Marvels. In this lesson, we're going to talk about congruent and similar figures and learn how to recognize a congruent figure from sight and distinguish it from a similar figure. So very quick notes I want you to think about when we think about congruent figures, congruent polygons. Think about this. They have the same, so same sides and angles. When we have things that are two figures that are similar, they'll have the same angles, different sides. And when we talk about figures that are congruent or angles that are congruent, we're going to use an equal sign and we're going to put a squiggly little line right on top of it. All right, so let's look at the obvious one here. Here we have two congruent triangles. They are exactly the same. What's different about them is position. One has just been moved around. As a matter of fact, if I took this triangle ABC and literally flipped it over, I can literally overlay it on top of the other one because they're the exact same size and measurements, even though they're different triangles by name. Names are different, but the measurements are exactly the same. And so their angles are also the same. And that's why we use this notation here to say that this triangle ABC is congruent to DEF. You're going to see different types of symbols and writings on figures because we're going to learn how to mark them and show what matches and what is equal on both. And you're going to see just little dashes or little arcs for that. So for example, let's look at the right angle on both. So you might see an arc. And if I use one arc on both, because they are corresponding, they match one another completely. And I might use two arcs to show that another pair of angles correspond with one another. You might also see an arc with lines. So I've seen that before. It's actually what I used to use when I was in high school, the little lines. But don't be surprised. So you're going to see these different notations throughout the unit. So you can have two figures that are congruent. You can also have angles that are congruent, just like these two down here. And you'll notice that we're using the full names for both. And whenever we use that symbol, it means that they are the exact same measure. They are congruent to one another. Now, so congruent, you can see them. They look the same. It just looks like one has been moved. In this case, this one has been flipped over and moved to the side, rotated a little bit. Obviously, these two over here are not congruent. They are different sizes completely, but the angles are the same. So because the angles are the exact same, and I'm going to use a highlighter. So sometimes when you're in class, you can use a highlighter to show what matches what. The angles will be the same, but the sides are different. We can use the term similar. And when you were in 7th grade, you talked about shapes with scale factor. We knew that they were proportional to one another, meaning the sides were magnified by a certain ratio. Very similar. We're going to have similar conversations about this later. Well, let's pause for a second so you can at least jot down these quick notes. We're going to look at the term corresponding. And when you see the term corresponding, think about matches. What matches what? And I'm going to use the highlighter for here. Some kids like using the dashes and arcs. Honestly, some kids are just more into the colors. The colors really help. So look at these two figures and see if you can figure out what matches what. So hit pause for a second and try and think which sides would match each other. And I'm going to tell you that these two trapezoids are exactly the same. They are congruent. So try and figure out which sides match. All right, so I'm going to start with the one that stood out to me most. This slanted side to this slanted side seemed to match to me. AB and FG corresponded. They matched one another. And opposite of them, the side with two right angles, DC and EH, were matching. So I saw that. I also noticed when this one here, the smaller base seemed to match, and that would mean my last pair, FG and BC, were also matching. So for some kids, the colors stand out way more, and that helps. So my advice would be, if these really help you, you can use your highlighters. Challenge is highlighters do not erase. So until you're really proficient and you're very sure about which size correspond, you may not want to use highlighters all the time until you know you have full mastery and you can recognize it. But I will say that a lot of kids tell me that they would rather use a highlighter with different colors than to use the dash. Like, that stands out to them more than these symbols. And again, doesn't matter to me, math marbles, whatever works for you. I will say the dashes might be a little easier if you use pencil because you could erase them. But if colors work for you and it pops out to you better, use that. Other people are also really good spatially, and they can just see that, like, what if I took this figure and just rotated it a little bit? And so if you're a spatial thinker, like, you can literally look at two figures and your brain can move them to see what matches what. Oh, this is going to be your unit. Like, your brain is just so aligned to this. But no matter how your brain thinks about shapes and sees things, we're going to find a method that works for you. All right, so let's talk sides for a little bit, and let's look at the notations for sides. And I'm just going to write two of them for two examples. So I would say DA corresponds with EF. So that's just one pair. Notice notation I'm using. I'm using that little arrow to show those two match one another. I would also, I'm just choosing another one. HG corresponds with BC. So you can see which ones match one another as well. Let's talk angles. And again, hit pause, try and see which angles match one another. And this one might be a little trickier for some, but again, you're thinking about the position of the angles in relation to the sides. So hit pause, what do you see? Great. Now, if this was hard for you, if you were able to find some that matched, fantastic. Sometimes it's a little bit challenging, so I'm just going to give you a little sneak peek into my mind. And what I used to do as a kid, I used to sometimes, I'm going to take my highlighter for a second. I'm going to look at this angle here. What I used to do sometimes, I would look to see, like, what's the position of this angle here, angle ADC. Well, I know it's between the 1 dash and the 3. So I would just look. If your brain spatially doesn't see it, I would just look for the 1 and the 3. I'm looking for markers that would tell me the position for the other one. So again, if this works for your brain, you can do that. And now I can see those two are in the same position in relation to the lines. And so even if something is flipped, even if it's flipped or rotated, I know it. That angle is between those two lines. So let's write this down. Angle ADC corresponds to angle HEF. Let's just pick another angle. I'm going to choose this angle here. Let me use the two little dash marks on it. All right, so I know that it is between the blank and the 2. So I'm looking, I'm seeing it's between the 2 and the blank is between. So here's the 2, here's my blank. So I know I'm talking about this angle right here. So again, I just use markers to just help me find things, find my locations. Like when I'm lost walking in the street, I look for markers, like where's that McDonald's? Where's that street? I'm looking for any visual cue to help me with my position to figure out where I am. So ABC corresponds to FGH, angle FGH. All right, I just chose 2. So now you got another example, Math Marvel, where you can use different symbols and structures and supports to help you locate corresponding or matching sides and angles. So hit pause so you can jot this down. And let's do a quick example. Okay, here you have another polygon. I can see the directions, they are congruent. So we want to name corresponding angles and corresponding sides. I'm just going to name 2. There are multiples in this one. So let's start with sides. And then we'll do angles. All right, I'm going to use my highlighter to help me again. And I will tell you these 2. This is a parallelogram. These 2 correspond with one another. They are the same. And as a matter of fact, because of the parallelogram, we actually have other sides that are congruent, but I want to just choose a side congruent that corresponds to another side on the other figure. So let's write this down. Side LM corresponds with WX. And let's just pick long side. And this one's pretty easy, right? Because you have a short side and a long side. So MN corresponds with XY. Okay, now let's try also with angles. And again, take a look. Take a look at the angles, and I see acute angles and obtuse angles. So again, positioning helps. I'm actually going to name this angle here. Between the two lines, I can see they match. So let's name them. Angle LMN corresponds to angle WXY. I might see some kids write it this way. Angle M corresponds to angle X. I really do prefer using all three letters because we might have more complicated figures or figures that have multiple lines. So for example, if I had something like this, here's an angle, here's point P, X, Y, Z. I might say angle P, but you don't know if I mean like this angle, you don't know if I mean this angle, you don't know if I mean this whole big angle. So just be aware of what kind of figures you're talking about. Okay, and let's just pick another type of angle. I'm going to pick this one down here, just so we have another corresponding MNP, and this one corresponds with XYZ. All right, so hit pause so you can jot this one down in your notes. And again, you might have more additional answers here. So let's do one last one so we can get to practice. I think you're getting this from sight. All right, so let's look at what is congruent. I kind of already started out the problem for you, which ones are congruent to one another. And how do I know, Math Marbles? Here, what do you see? What do you notice? Why do I know that these two are congruent to each other and not square B? What is the big clue here? What is it? It's the sides. Like the angles are all the same. These are rectangles. We know they all have right angles. Well, they're squares, and I can call them rectangles as well because they have all right angles, and they're squares because they have all the same size. But the reason I can say that square A is congruent to square C is because the sides are the same. Like the angles are all the same in all three figures, so I know they're all similar to each other, but because these have side measurements of 8 and 8, they're congruent. Not this one. This one was just there. That one, it would be a similar to. It's similar, but it's not the same. And it doesn't even matter that I rotated it. Like, that's the other thing. So what if this one is rotated and just moved around? It's the same figure. These two are the exact same size and measurements. So that's the other thing I want you to look out for, recognizing that they are the same. Even if I take it and I take the figure and I try to like rotate it and turn it on its side, I can still recognize by the measurements and the angles if they're congruent. All right, so we have lots of things to practice in this lesson, so I'm going to stop here for now. Take your time, and if you're really struggling with measurements, talk to your teachers, talk to your teammates, and see what they're thinking about to be able to recognize congruent or distinguish it from a similar figure. Talk to other people to get ideas. That's how we learn together. Okay, Math Marbles? I will see you in the next lesson.